the idea of independence of path is pretty important. So let's take a little bit and talk about this and kind of define it a little bit. Now let's suppose that C1 and C2 are two curves, and we're talking about curves through a vector field. We're talking about paths that we're taking with the same starting and ending points. Now, by the same starting and ending points, what I mean is they both start at A and they end at B. So perhaps this curve starts here at point A and goes to point B. Maybe this is C1, and C2 over here someplace starts at A, does its thing, and ends at B. That's what I mean by the same starting and ending points. I'm not talking about a curve that starts at A and ends at A. That's something totally different. Okay, so I have these two curves with the same starting and ending points. Now we know that in general, the line integral over C1 is not equal to the line integral C2. So in general, the path is important. We need to know what path we actually took through this vector field to compute the line integral. But an extremely important implication of a conservative vector field is that the evaluation of this line integral is actually dependent only on its starting and ending points. That's it. So because of that, specifically for a conservative vector field, the line integral over C1 of the gradient of f dot dr is in fact equal to the line integral over C2 of the gradient of f dot dr. Now this is provided the gradient is continuous. So the line integral of a conservative vector field depends only on the initial and ending points on C. So in general, if this vector field is a continuous vector field with some domain D, we say that the line integral, the vector field dr, is independent of path if it's true that the line integral over C1 of f dot dr is equal to the line integral over the second curve f dot dr. And it's important to say here, or add to this, for any two paths, C1 and C2 in the domain D, that of course have the same starting and ending points. Now, based on all of this, what we say is simply that line integrals of conservative vector fields are in fact path independent. And that is the major punchline to all of this right there.